Okay. Because one thing that's not allowed is if I put stuff on the internet, I can't put stuff on the internet with students' faces in there. I'm not allowed to under these YouTube regulations. So I've just restarted. Okay. So and means times and O means plus. Okay, lovely. So let's have a look at this first basic level of question, which it gives us in a form of a tree diagram. So that's just one way we can display. So let's have a look at question number 5. So question number 5, let's have Arwa. Read question number 5 for me, please.
2/3 of the cars on British roads are of foreign manufacture. Copy and complete this tree diagram to find A, P, the next 2 cars you see being British made, and B, P, the next 2 cars you see not being British made.
Lovely. Okay, so let's look at the tree diagram which they've already drawn for you. Normally, they won't ask you to draw a tree diagram, Anaya. Normally, they won't ask you to draw the tree diagram. The tree diagram will already be drawn for you. So that's not really a prerequisite skill where you have to do it at normally. Normally, they'll give you a question of the tree diagram with the tree diagram drawn and everything missing, and you got to fill in the details. That's what we're going to be doing now. So carry on, Arva. So now, if the probability on this first branch here, I'll just quickly highlight it in orange. The bottom branch is 2/3. What's special about the probability that has to go here? It can only be one particular fraction, and it's due to a particular rule. What must that number be?
It has to be 1/3 because it adds up to 1.
Fantastic, lovely. So on any particular branch of the, brother, you can't see on the board. You guys are so sleepy. Yeah, and you're sitting there. You haven't even told me that you can't see it. I don't know what's worse, the other class or you guys.
So I'm the best.
Yeah, the best. They're sitting there like I don't know what I don't know. I don't want to use that word because you're recording at the moment. I just use the word sleepy. Yeah, students just sitting there like statues, and they haven't told me that the projector's not on. Okay. What can I say? Now, what about the next part of the diagram? So the first part of the diagram, that always adds up to 1. And the next part of the diagram, what will it be if I do this part and this part? Will they be different or the same as what we've just done?
The same.
They'll be the same. Nothing's changed. So these will be identically the same probability happening for the next 2. It is not dependent on the first, what happens first. Right, what about the bottom one?
The same.
The same. Okay, now there will be other questions that we do later on. They will change. So that at the moment is fine. Now, let me rub off the highlight and let's get back to the question. So let's use a different highlight. Now, this question here, read the question and what does that mean?
The probability of the next 2 cars you see being British made.
So that means we've got to travel along here and then travel along there. Now, whenever we travel along the probability tree diagram in going across the diagram, what's oh, let's move this out of the way. Okay, what's assumed? Right, let me just switch my camera off because I have a feeling it's gonna cover. Yeah, that's better. Right. When we go from one end to the other end, what's assumed that we're doing is an and or an or when we go
and.
So it's probability of a British and the probability of a British. So probability British and probability of British. So what do we do with those 2 numbers and 1/3, 1/3?
Multiply them.
So 1/3 times by 1/3. You should be able to fit all these onto your sheet. So annotate on your sheets. You don't need to do them in your books at the moment. So 1/3 times by 1/3 will give us
1/9.
Fantastic. Oops, what's going on there? Right, excuse me about that. I don't know what's happened there. So that'll give you 1/9. Fantastic, lovely. Okay, so you answered question A. Right, let me choose a different highlighter. Can you read this part of the question now?
The probability of the next 2 cars you see not being British made.
So what does that mean?
The foreign cars.
It'll be foreign followed by another?
Foreign.
Oh, excellent. So probability of a foreign and the probability of a foreigner. This is how I want you to do your annotations, P little f and P little f. Now they haven't used the word and, have they, Abdullah? There's a probability, next two cars you see, in the next two cars has got a built-in and in there, which means the first car and the second car. That's implied. The and is implied from the wording, even though it's not in the wording, it's implied. Probability of f and probability of f, which is going to be what this time, Arwa? Give me the numbers, please.
2/3 times 2/3.
Fantastic. 2/3 times by 2/3. And what's the answer to that?
4/9.
Fantastic. Lovely. Good. So that's the that's like a very basic level of filling in the tree diagram and navigating around the tree diagram on a basic level. Question number 6 and 7, they're very similar. Okay, because the question changes a bit when you get to number 8. Okay, everybody have a go at those couple of questions. Now that you've seen how I've done that one, fill up the page, and then I'm just going to quickly check with some answer. Everybody, go. Anybody doesn't know what to do, ask me and I'll. Yes.
Finish the page.
Say that again.
Finish the page.
Okay, so Asadullah, again, are you supposed to start the question and finish them before I've told you to start and finish them?
No.
So if you're doing something which is not correct, and then you are very happy to show it off, so I've already finished it. It doesn't even make sense to me. I've told that about in the lesson last time. Don't do the questions before I tell you to do the questions. So what I'm going to start doing, if you do that again, Asadullah, I'm going to put you in the waiting room. Do you want me to put you in the waiting room, Asadullah?
No.
What are you going to learn in the waiting room?
Nothing.
Nothing. Yeah. So follow instructions and do not do the questions before I tell you to do the questions. So while I'm going through the example, you finishing the page off. You're a proper doctor, you are. Imagine you working in the NHS. The patient hasn't even got ready and you're ready for an operation. Without the, anybody else? Okay, good.
Do we just do questions?
A 6 to 8. Fill in the diagrams, answer the questions, do the annotations. You could do them by the diagram or by the question. Show the annotation, P of the whatever, big P, little letters for the other ones, and the fractions, timesing them.
So,
Yes.
you know, for 6,
Yeah.
it says to find P, and then for question A, it says having stew on both days. So you
How would you show that?
Sorry?
How would you show that on the annotation? Yeah.
Oh, you complete the table. So you put no stew.
There you go. Probability is stew, probability is stew. If it says no stew on either day, probability of no stew written with a dash on top, like that. Or you can use the language probability of no stew and probability of no stew. This is your annotation. Remember the NS and the S's have to be small and at the bottom. Small and at the bottom.
Okay.
Okay?
Yeah.
That's when I say annotation, I mean this is the kind of wording, this is your idea. You're explaining to me how you're thinking of the question.
Oh, okay.
Okay. So probability of having stew on both days means first day and the second day. That's our interpretation of the English word. Good.
Okay, thanks.
No problem. I'll just zoom it back out. Okay, where is Abdi in? Oh, let's come in here. Give me a second. So send the message. Where's he gone? Okay. So that'll be 1/4 down by 1/4 is 1/16. And the next one having stew on either day, not having stew, what will that be?
3/4 times by 3/4 equals 9/16.
Because not, when it says on either day, that means and the and is represented by the times. Excellent. Okay, question number 7, Abdullah, at the back of the class, 7A, quickly.
1/3 times 1/3, which is 1/9.
And the next one,
1/3 times 2/3, which is 4/9.
that one. Okay, why is that different? Neither house having a child. Shouldn't it be 2/3 squared? 2/3 times by 2/3,
Oh wait, yeah, I did 2/3 times by 2/3, which is slightly
which equals to what? 4/9.
which is slightly wrong.
No problem. Okay, so question number, have you done question number 8, everybody? The June winter rains on 3/5 of all of the days. I think it's more like 5/5. So 3/5 and 2/5 and 3/5 and 2/5 and 3/5 and 2/5. So 2 successive days is easy. So being fine, being rain. Okay. Now question C, you've done it. So it says the first day being wet and the second day being fine. So now let me give you new wording. Probability okay, so let's have Essen read the question which I've annotated in the bottom. And can you explain to us what does that question mean? The wording of my one, which is quite different than all the other printed ones. What does that question mean? The one in red.
1 day fine and 1 day wet.
Okay,
So
go on.
do you do 3/5 times 2/5 for wet and then fine,
And then
and then you do 2/5 times 3/5 for fine and then wet, and then you add them together.
fantastic, lovely. That's what we do. Exactly what we do. So 1 day fine and 1 day wet with no order on it, which basically means you're going to have 1 wet day, 1 dry day. And that happens in how many different ways? 2 different ways. It either happens by wet fine or fine wet. So in this part of the diagram, we got more than 1 branch highlighted. Before we had 1. Now we got 2 highlighted. So let's do some annotations to show the calculation. So that'll be probability of wet and probability of fine, or probability of fine and the probability of wet. So that's my idea line. Okay, the next line down is going to be probability of wet is going to be this fraction here. I'm on the top one, 3/5 times by 2/5, is it? O means plus, big plus, because it's O. Probability of fine for the, so on the bottom, I'm on the green one now. So it's 2/5 times by the 3/5. I'll color code it for you. That's the green one. That's the orange one. I'm just going to carry on down at the bottom. So 3, okay, so Anaya, what do you get for the first part? Okay, Inaya, what do you get for the second part? Abdullah, what do you get for the total for the answer? Okay, lovely. And that's the answer to that question. So you got to look at the wording. What does the wording mean? What is implied? 1 day fine and 1 day wet means in any order. They don't need to on purposely make everything so clear. They don't have to say in any order. That's implied automatically from the wording. It's assumed that you know that. Okay. The other one, the other wording for C is the first day being wet and the second day being fine. That's very specific. You can't get that wrong. Okay. Are we happy with that? Okay, so right. Okay, question number 9 is straightforward. Question number 10 has got 3 parts to it. Question number 11, 12. Ooh, okay. You're getting a bit more exciting. So question number 10, 11, 12. So now you got 3 parts, nothing to be scared about, 3-part questions. And also nothing to be scared about if they got bits of the diagram missing. For example, here is all going to the top. Nothing to be worried about. So question number 10, 11, 12. Okay, off you go. Fill in the probabilities, have a go at the questions. Okay.
So do we finish all 10, 11, 12?
You should have already finished them by now. You should have finished them yesterday.
No, I'm doing it as we go now.
Oh, you are. Oh,
Yeah.
that's strange for you. That's good. Yeah, do them. So look at all the paths. Okay, Mr. Rion. How are you doing, Mr. Rion? Did you manage to get the email and print the stuff out?
I don't have a printer.
Oh my God, another one of those special students who's lived life through lockdown without a printer.
Yeah.
What a naughty boy. You should tell your Abuji to buy a printer for the house.
We did. It broke.
Was it your brother? Did
Well, it didn't break. He just wouldn't buy the ink cartridge. It's a bit too cheap.
Okay, that one. Okay.
Have a word with him.
Yeah, I will have a word with you, Dan. So I'm gonna have to clamp his car. Okay, boarding book runs overdue. Okay, when you finish, you can lift up your head and have a look at the screen. For those of you who are looking down and doing your own work. I've done a little bit cancelling. If you haven't done cancelling, then you can cancel your fractions down. You might have slightly different answers.
So I got them all right.
Okay, Arwa, how are you doing with the questions?
I got them all right.
Okay, can you give me your answers for question 10A, please? The top one. That you'll see adverts on all three times.
I got 1 out of 64 for A.
Correct. And what do you get for B?
21 out of 64.
Okay, so is it 3/4 term? Are you sure it's 21? So the 64 on the bottom number is correct. 3 cubed. What's 3 cubed?
27.
Oh, 27.
Okay. Okay, Mr. Asadullah, give the student a chance to correct herself, yeah? Jazakallah for your input, but you know, if you can't answer, then I'll give you a go, okay? Okay, well done, Arwa. 27 over 64. So there's all your answers for the questions that we just done now. And can you just, everybody, can you type into the chat how many of those questions you got right? So there's 1, 2, 3, 4, 5, 6, 7, 8 questions. Type into the chat how many you've managed to get right. Let me put my chat actually on. Here we go. Right, everybody just quickly type it in, yes? So we should have 1, 2, 3, 4, 5, 6. 6 people answering, writing it. Okay, good. 7 or 8. Mhm. Yes. I've just cancelled mine. I don't normally cancel that. I just saw some numbers that cancel. Okay. Essen, which ones you got wrong? Which one didn't you understand, Essen? Oh, you just done less. Okay. Abdullah, any questions you want me to go through, or is that how many you've done?
How many I'm done? I finished.
Okay, lovely. Well, are we ready to move on?
I think so.
Okay, well, let's just have a look what else we're supposed to be doing. Okay. These are examination style questions, and the first couple of ones are quite easy. So we could actually do those. But there's also some other, we'll be doing also questions without replacement as well. These all questions are questions where the second part of the tree doesn't change. So let's have a look at a grade, I think this is a grade C type question. Nice straightforward question. Question number 4. Let's have Eliza. Question number 4, the question is yours, go for it.
The probability that a biased dice will land on a 4 is 0.2. Pam is going to roll the dice 200 times. Work out an estimate for the number of times the dice will land on a 4.
So the key parts, I've highlighted them. So what does the word estimate mean to you? What do they want you to do? Does the word estimate literally mean estimate? Like, do they want you to guess it or round it? What does the word mean in the context of this question?
They want you to like round it.
Okay, in this particular context, they actually want you to do a calculation. So an estimate is actually assumed by the nature of the calculation. So how many times did you repeat the experiment? The experiment was repeated how many times?
200.
Okay, and what was the probability of the event happening?
0.2.
So if you repeat something 200 times, that's supposed to happen 0.2 of the times. So what do we do with those two numbers?
You have to time them together.
You have to times them together because 20% of the time you expect it to land on a 4. That's what I mean when you say estimate, because that's our theoretical probability. That's what we expect. It's not going to be necessarily what you can get in reality. That's why it's called like an estimate. So we're doing it on theory basis. Yeah, in reality, it'll be a little bit up or a little bit down. That's where the estimate part comes in. So we have 200 and the 0.2. Could we change that into 2/10?
Yeah.
Okay, now can you now deal with that in a better way than 0.2? Can you sort that out for me now?
Can you just like cancel it? So you put a 1 over, so you can put a 1 under the 200 and just cancel it that way.
Yeah, you could put a 1 under the 200, turn them, they look both like fractions, divide by 10 diagonally. So what's the final answer?
40.
Fantastic. Okay, lovely for that. Question B, let's have, okay, let's have Essen. Question B, please. Start reading it from here.
The probability the dice will land on 6 is 0.4. Ted rolls the dice, rolls the biased dice once. Work out the probability the dice will land on either 4 or 6.
Okay, now what is the key word that they've mentioned, that they've actually mentioned?
Or.
Oh, okay, so the probability of a 4 or the probability of a 6.
So you work them both out and then you just add them.
So what was the probability of a 4, by the way, first of all?
0.2.
And what is the probability of a 6?
0.4.
And what are those two added together?
0.6.
And that's your final answer. You can give the answer as a decimal, as a fraction, or even as a percentage. All those 3 answers are equivalent to each other and they are all perfectly acceptable. So here goes, just work out the probability we have. And they haven't mentioned that they do it 200 times. So it's a different type of question. Are we happy with question number 4?
Yes.
Yeah? Okay. Arva, read question number 9 for me, please.
Here is a 4-sided spinner. The sides of the spinner are labeled 1, 2, 3, and 4. The spinner is biased. The probability that the spinner will land on each of the numbers 2 and 3 is given in the table. The probability that the spinner will land on 1 is equal to the probability that it will land on 4.
Lovely. Okay, now, a quick question that I didn't ask before. What is the probability of something happening? What's the total probability? So, for example, Arva, if I was to add up all these numbers here, what answer will I always get?
1.
Fantastic, 1. So the probability of everything in the equation happening is 1. So, and can you explain to us what this word here means, which is highlighted?
It's more likely to land on something.
Yeah, it's more likely to land on some than the others, so it's biased.
Unfair.
So now, if you look at the values, you can already see the biasness from the numbers are not equal. If you have a 4-sided spinner which is not biased, then you would have all the numbers would be equal, 0.25 all the way around. Now, okay, so Arva, what do these two numbers add up together at the moment?
0.5.
So how much do you have left from your 1 note left over?
0.5.
0.5 is left over. And that 0.5 is worth this one and that one, and they are equal to each other. So what do we do to the 0.5?
Divided by 2.
Which gives us?
0.25.
So what's the value of x?
0.25.
Okay, lovely. Everything which I'm writing on the page, okay, obviously don't write. Okay, that's a little bit of a bad example. I've kind of written across there. I shouldn't really write there. There we go, that's better. Do all your annotation, all the calculations, write them down.
Sir,
Yes.
just to make it easier for yourself, can you just do x plus 0.3 plus 0.2 plus x equals 1, and you just like
yeah, you mean like form an equation and solve it? Yeah, by all means, you can do that.
Oh, okay.
That's lovely. Okay, right. Arva, finish up the question for me, please.
Sarah is going to spin the spinner 200 times. Work out an estimate for the number of times it will land on 2.
So let's have a look. What was the probability it land on 2 in the first place?
0.3.
So we do 200 times by 0.3, which to make it a little bit nicer for us to do with our calculator, we change it into fraction style. Can you cancel that down for me, please, Arva?
It's 20 times 3.
Good. So we're canceling this diagonal by 10. We knock off a 0 each time. 20 times by 3. So how many times are you expecting to get the 2? The answer is
60.
60 times. We expect it for it to land on a 2. So this is that nice kind of foundation level of probability questions that you can get without involving tree diagrams and anything complicated. Okay, here we go. Here we start looking at exam questions where the tree diagrams were given. Okay, Abdullah at the back of the class, read.
Revision classes are held after school. Jericho always attends these classes on a Tuesday and Wednesday. You can choose maths, English, or science to study on each day. The probability that he chooses maths is 0.4. The probability that he chooses English is 0.1. Assume J's choices are independent. Complete the tree diagram below. So
when he says independent, what does it mean? So what you do on Wednesday is not connected to what you do on Tuesday. So they're not going to be affected. So so the probability is going to be the same each time he does it. It's not going to be, if I've done it the first time, it's going to be less chance or more chance. It's identical. So Abdullah, can you then fill it? So you got 0.4, 0.1. What goes at the bottom? 0.5. And then what can we say for the other 3 parts of the diagram? They're going to be the same. So we can start filling them in identical to the first part, especially this part here has got nothing written on it. We can just copy it across exactly as the others. So this is for this particular style of question, because of the wording of the question as independent, it will be automatically the same. But not every question you do will have all the same numbers going across. Sometimes there'll be different things happening. Yes.
All this, this topic, is that like, will it come on a high paper or will it mostly come only in foundation?
Say that again. This question here.
Yeah, like
This question is your typical
probably.
kind of overlap type question, which will be overlap from foundation into higher. So, but we haven't got to the higher questions yet.
Oh, okay.
So, I mean, obviously, you don't want me to start teaching you the higher questions first.
Yeah.
That might cause a bit of mental constipation, and we don't want that now.
That's okay.
Then we're gonna have to give you some, I don't know, all kinds of stuff to relieve you of that situation. Right. Okay. Question B. Who was doing that question? Abdullah at the back of the class. Where have you gone? Go and read.
Work out the probability that Jeha chooses the same subject on Tuesday and Wednesday.
So what does that mean to you?
That on both days she's choosing the same.
So for example, maths, right, done?
Or English.
Or English, or science. Write that down. So the probability of maths, or probability of English and probability of English, or probability of science and probability of science. That's important. That's your idea line. That's you telling yourself, telling the examiner, this is how I think of the question. Okay, done. Now, give me a layer of maths now. Let's put some numbers. So from the diagram, the maths marks are what? 0.4 times by 0.4. And what does the O mean? Means add. Put some two big, heavy, big, fat add. Next one. Back to the blue. What's the probability of English? English?
0.1.
Lovely. What's the probability of two sciences? Double science?
0.5.
Okay, now remember we're doing all of this with our calculator at the moment, right? So let's ask some of the questions from the Salia. 0.4 times by 0.4 gives us, with our calculator, 0.16 is beautiful. Inaya with the I, 0.1 times by 0.1, 0.01. And 0.5 times by 0.5, Anaya with the A, 0.25. Okay, I'm kind of slightly crashing into the answer area. I'm just going to resize this. And okie dokie over here. That's better. Right. Okay, back to you, Abdullah at the back. What's the total now for all that?
We've got 0.42.
Fantastic. So 0.42 or 42 over 100 or 42%, all viable answers. Okay, so in that particular question, we had a lot more going on. On number 8, I'm going to add on some extra questions. Question number 8. Let's have Abdullah B at home. Abdullah.
Yes.
Read, please. Iqra.
Okay. Inshallah. Ami has 10 CDs in a CD holder. Ami's favorite group is edX. She has 6 edX CDs in the CD holder. Ami takes one of these 10 CDs at random. She writes down whether or not it is an edX CD. She puts the CD back in the holder. Ami again takes one of these 10 CDs at random. Complete the probability tree diagram.
Okay, now, which is the critical word in this particular question? One very critical word.
Back.
She puts the CD back. So what's that called in probability language? It's
I'm not
called
sure.
with
repetition. Replacement.
With replacement. When you put the thing back in, what happens to probability the next time you do it? It stays the same. That's the point they're trying to make. If you're doing a question, you're taking something out, and before you do it again the second time, you put it back in, then you haven't changed the probabilities of again the second time. So that's going to be 0.6 And the bottom part is going to be what? 0 point?
0 point, what is it? 0.10.
0.4. Because
Oh,
it's got to add up to 1.0. Or are you trying to say 0.10? I don't know what that is. But
Oh.
I can see. What goes here?
the same thing, 0.6.
Exactly, because the probabilities haven't changed.
Same.
Independent. Okay. So, read question B for me, please.
Find the probability that Amy will pick 2 EDX CDs.
So let's have a look. Let's get ourselves a highlighter. So she's got to pick the first one, and then she's got to pick
The second one.
So it'll be the probability of edX and the probability of edX. That's what it means. So when they're saying pick 2, what's invisible in the 2? What sign is it? Oops.
Add.
It's an and.
Yeah.
There's an invisible and implied when it says 2, because it means the first one and the second one. So there's where the and is here. So you must write down the idea line. Yeah, this is the idea line. So probability of edX is going to be what? 0.6
times
0.6, which is equal to
0.36.
Okay, don't say 0.36. That's poor maths, because there's no such number in the world called 0.36. You must read the numbers after decimal point individually. 0.36. Now, here's where I'm going to make this question a little bit more interesting by changing the wording. Right, or introduce new ones. So what's the probability of getting the same choice on both goes? So that's the next question. I'm going to rub off the highlighter now, so then we can redo that question. For that question now, I'm going to ask a different student. Everybody think about that first for a moment. I want you to chew that under your molars. And okay, Anaya, do you know what that question means? Okay, have a go at that question right now. If you think you know what that question means, implies, probability that you get the same choice when you do it twice. Do your idea, do the calculation, and then I will recap it with you in a second with another student. Okay. Yes, Rion, you can send your homework by email. Yes. Blah, 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 blah. Okay, and also let me give another wording. Probability. Okay, Mr. Abdul Hamid. Yeah, we got him in. Okay. Assalamu alaikum, Mr. Abdul Hamid. I'll put another question on there for you. I'll put 2 new questions on there. Okay, the last one. You got how many components do you have for the last one? 2. That,
literally one 0.4 times 0.6.
I'll show you in a second. Okay, right. I need some. Okay, I think I already got one person that I'm thinking of choosing for this question. Right, does anybody need any more time to do these questions? So this question here, question number 8, is the one where I introduced my own questions, which are the bottom 2, just because this got missed out on the recording. So when we say probability of the same choice, it means it's going to be edX, edX, or not edX, not edX, which is what we've done here. And we worked that out, and that gave us 0.52. Then I gave another worded question of the style of exam question, probability of at least 1 edX. Probability of at least 1 edX is shown on the tree diagram in the highlighted 3 paths, 1, 2, and 3. And that gives us 1, 2, and 3. So we work those out, those calculations. And we got 0.84. That's where we got to. Okay, right. So we have to try to go a little bit slower. Arwa, how are we doing with the Arwa saying okay? Rian saying that he's tired. Allahu Akbar. Rian should lie down, man. Get the sofa, go on the sofa, lie down, close your eyes. And when Abuji asked you, did you pay attention? I said, yeah, Abu, I was until I felt tired. So it told me to lie down, so I went to sleep. Yeah, don't do that actually, because you get tired. You won't be. Sorry about the noise. I think my family members trying to break into the classroom. Okay. All right, let's move on. Okay. Oof, question number 13 is Jamil. Okay, everybody, question number 13. I'm releasing you guys into the wild. Off you go, do question number 13. That looks like a bad boy question. Okay, question number 13 is for everyone. Okay, Mr. Abdullah, you don't have time to finish the question. You need to take the blue pill, Mr. Abdullah. You remember the Matrix? Had the children the red pill and the blue pill.
No, I don't watch that.
You watch the Matrix. I don't blame you. Okay. Abdullah, did you watch Ben 10?
Yeah.
Yeah,
Used to.
Yeah, but there's no harm. I've been watching Ben 10 till about 10 years ago. I was a grown man watching with my kids is fantastic. Especially when you watch CBBS in the night garden and stuff, right? Eagle Pickle and stuff. They're the best. Better than Top Gear.
Yeah.
Okay, now if anybody gets question C right, they are in for some merits. If I can give you merits, I don't know.
I want snacks.
Yeah, you get.
I want a pack of M&Ms.
You want to pack them? I already eaten them.
That's what I want to do.
Okay. Question number 13, examination question for you guys to practice.
I don't know how to do that underneath. You know, Amy, when Amy.
Oh, yeah. Oh, by the way, we've got this nice new word.
Exactly.
Hi, Allahu Akbar, beautiful. Okay, first of all, anybody feeling brave in the class to help the class start the question and explain how we or what exactly means to them? Put your hand up if you're at home and you're feeling you've eaten the brave pill and you want to explain what the word means exactly. Because we've done words like before, same, at least, and stuff, both. Okay, anybody can do it?
The divide.
Allahu Akbar, what are you talking about, young man? No. No. Okay, no. Oh, when did I start recording? Started recording. Do you record to the break? I have to do some editing. Okay, anybody know exactly what it means? Okay, essence means just one.
Does it mean the same?
Okay, essence hit it on the head. Exactly one means it only can be one of the winds. Now, essence, does it mean this? Do that and I stop. Essence, explain. I'm trying to. So it says exactly one win. Okay, have I done that right then, Abdullah?
Yeah.
Ah, no. You still got to do two. You got to win the first one and then lose the second one, or you lose the first one and then win. Because the key thing here is that in the path you have the winning part. Oops. The winning part only happens once in the first path and once in the second one. Okay, I hope that helps with the question. Jay. Okay, Atik. All right, very good. Okay, so we have 1/3 and 2/3. Okay. All right, give me one moment, folks. Okay. All right. It's muted. Okay, right. So work out probably that Amy will win exactly one game. Solid go.
Would you times 3 over 4?
3 over 4 times by, and then
1 over 4 over 1 over 2.
so we're going to do 3 over 4 times by 2 over 3, which is probability of win and probability of not win, or probability of not win, which is dash, and the probability that she will win. In those, you've only got one chance of winning. Okay, O means plus. So quarter times by a third, the bottom of path. So what's the answer for this one? 3/4 times by 2/3 will give us what?
6 over 12
Plus.
plus 1 over 20.
Okay, I've written this down. That should be, I think, 1/3. That's just me writing it down a bit dodgy. Give me a second. That's
How would you do that?
no, it's no. We've written it down. It's 1 over 12. That's a 3. And the final answer is
7 over 12.
okay, right. Question C. If anybody at home is doing question C, can you please share the answer with me on the chat? Before you share it, wait for a second. Let me change the settings so you can only share it with the answer with me. Nobody else can copy your answer. Go. So if everybody at home, if you've done question C and you're happy to share the answer with me, then please send it through. Okay. Don't rush. We might trip over each other. Okay, have you guys done your answers? Okay, so for question C, we're gonna get Anaya with the A. She's gonna help us understand. Okay, folks. So far nobody sent answers through. Is it because we're all sleepy at home, or we all sleeping? Yeah. Where's everybody gone? There's nothing. No answer come through. Has nobody done C at home? Allah. No. Oh my dies. They haven't done it. Okay, come on, Anaya with the A. You have to save the day. Explain to them what it means. Read the question.
Amy played one game of snooker and then one game of
Billiards.
Okay. On a number of Fridays, she won both snooker and billiards on 21 Fridays. Work out an estimate of the number of Fridays on which Amy did not win either game.
Did not win either game. So which part of the diagram are they talking about did not win either game? If I use a blue.
1/4 and 2/3.
Yeah, this part of the diagram. So let's have a look. Let's look at let's put some annotations. So the probability that she won both, yeah? So win and win. Yeah, so that'll give us a probability, yes? And then she done that for how many? She won at both of them on 21 Fridays. So she played for a number of Fridays. We don't know how many. So she played for a number of Fridays. And then the answer to that calculation is equal to 21. Okay, 21 is the answer. Okay, so what's the probability of winning a win-win? Anybody? Win-win is 3 over 4 times by 1 over 3. 3 over 4 times by 1 over 3, which gives you, is it 3 over 12? Okay, we're not doing cancelling at the moment. Don't worry about it cancelling at the moment. So that's 3 over 12. So 3 over 12 was a chance of her winning twice, and she played for a number of Fridays. When she played for a number of Fridays, which we don't know how many she played for, she got an answer. She won on 21 occasions. So what's that number going to be? Abdullah at the back of the classroom, how would you work that out? 21 divided by 3 over 12, which gives us 21 over 1 times by 12 over 3. We do the KFC without the finger licking, yeah? So we do the KFC, keep, flip, and change. Okay, then that cancels down with that. Yes, happy? So 7 times by 12 is? So on 84 Fridays, she done all this kind of, so 84 is the number goes into here. That's the missing number. But that's not really, because work as in, so we have to work that out first. Now we can actually do the question. So back to the question, Anaya with the A, read, work out
Work out an estimate for the number of Fridays on which Amy did not win either game.
So this is for that part here. So now, so we are now going to do that part here in blue. So work out the estimate of the number of Fridays in which Amy did not win either game, did not win either. So if you did not win either, that means it was 1/4 time by 2/3, isn't it? Probability of lose and probability of lose, or let's actually keep the context the same. Probability of win not. Okay. So what was the answer? 1/4 time by 2/3, yes? So 1/4 time by 2/3, which is equal to 2/12. Okay, now, so how many times did she do the experiment? We discovered 84 times. So 84 times she did it, and she can only lose on 2/12 of it. So 84 times by 2/12 gives us what is the answer?
Yes, 7.
So that'll give you 1. I'll give you 6, and 6 is into 84 is. Does it go? Yeah.
Yeah.
What's the answer? 14.
I think it's different way.
But did you get the right answer? It doesn't matter which way it is. Did you get that now? So this is like a reverse question. They're making you work backwards and forwards and stuff and do multiple parts and things. Okay. Hopefully, folks, that was a question that was a proper trick question. I've used this question for quite a few years, and nobody has ever got this question right by themselves, apart from today. Who got the answer? 14. So Abdul Hamid saying 14. He's the only one at home saying 14. Okay, Arva saying 63 Fridays. Okay, that was close to the 84, but not close to the 14 final answer. So how many people put your hand in the class if you got 14? Got 14. 1, 2, solid, no? No? Okay, do you understand how you got 14? So you got to go and work out first on how many times you played the game, how many games you, and from that, then you can use that to work out the actual for the new question. Okay, fantastic, lovely, and jubbly. Yeah, then you get 3 months. Yeah. Okay, before we do the rest of the questions, we need to introduce you to that one's easy. I don't know what that's doing over there. Question number 3 is easy peasy one. I don't know how it escaped and gone to there. The other ones are gonna blow some cylinders. No. Have you ever seen me with water next to me? No. Okay, question number 3 is the easy peasy one. Should be in the, I think that's printed in the wrong order. So everybody can have a go. Question number 3, quickly. Okay, Essence, you don't. Abdul didn't get it. Okay, right. Everybody have got question number 3 for Asin and Abdullah. Okay, Asin, for you and Mr. Abdullah, who else was it? Abdi Hamid. So it says here, so let me color code the question for you. So this question here is in green. This question here is in green. So the green bit is the green bit. So from the green bit on the top, we worked out backwards that she has been playing the game for 84 weeks. 84 Fridays she played based on the green part. And she won it on 21 because the probability of winning both is very small. It's a quarter of the time. So quarter of 84 gives you 21. So they gave you the quarter, they gave you the 21. You have to work out the missing value here. And that's what we've done. We've done a rearranging calculation and we worked it out. Okay, that's how the 84 came from. Then we have another second part of the question, the main part of the question, which is orange. This is the actual question. To do the orange one, now that we're going to reuse the 84 in our calculation to do the orange part. We work at the probability of winning twice, and then 84 times by the probability, that gives us an answer of 14. Hope that helps. So we have Shilpa Shetty from India. Okay, she's a Bollywood star. Okay, she's back in a school lunch. Okay, so we have 3/5. That should be 2/5, 1/3. That should be 2/3. Two totally different things. 1/3, 2/3. Right. So let's have an Anaya. So Inaya with the I. What's the answer for the probability that she'll pick a cheese and onion, nice and stinky, and probability of a chocolate biscuit?
2 over 5 times 1 over 3.
So this one and then that one.
Yeah.
So it'll be 2/5.
Yeah.
2/5 time by,
1/4,
which gives us
2 over 15.
nice baby question. Easy peasy lemon squeezy. Okay, right. Now, I need us to quickly skip to the last page, and then we're going to come back to those other questions. So I'm going to add a page on here. Okay, so, and I'm going to pick okay. So Arwa, can you read this word for me, please?
A bag contains 10 discs, 7 are black and 3 are white. A disc is selected and then replaced. A second disc is selected. Draw a tree diagram to show all the possible outcomes. Find the probability of the following. Both discs are black, both discs are white, and the 2 discs are different colors.
Okay, now, first things first, I mean, even though there's written in that particular question that they want you to draw, we don't normally, you're not going to be normally asked to draw any tree diagrams. That is slightly, that's not used anymore, that style. Now, what was the key word in our question?
Replaced.
Okay, now if you just quickly jump to the next question, what's the key word now?
Not replaced.
So it looks like it's the same question, I think, but no, these are different colors actually. Okay, so we can draw the tree diagram. We've got this hand from the just 2. Okay, right. Let's just copy out the question, and I want to focus on the second one. So I'm just going to cut this one out. You're going to do a copy and a paste. So everybody, I'm looking at question number 2. Okay, and it's saying that it wants us, yeah, we could draw a quick tree diagram. So everybody, okay, because it's got all those different colors. So it's got, oh, hang on a second. Oh, fantastic. I misread it. Give me a second. We actually don't need 3. We only need still 2. Because we got, what colors do we have? Green and blue. Green and blue. Green and blue. Okay, right. So it says here that we have 7 green. What's the probability of getting a green, Arwa?
7 over 10.
And probability of getting a blue?
3 over 10.
So they have to add up to 1. Now, this wording here, not replace. So basically, if you pick a green, you picked a green out. So how many greens do you have now to pick for the next go?
6.
6 out of
9.
Fantastic. So we lose 1 number from the bottom, 1 from the top, because now you have only 9 discs left and only 6 of them which are green. So you have to understand how the fractions change. And what about for the blue then? What will that be?
3 over 9.
Because they both got to add up to what?
1.
1 again. So these got to add up to 1. These got to add up to 1 like that. So what about if you choose a blue disc coming down the bottom now? You got 1 of the 3 blues out. How many? What's the chance of getting blue the next time?
2 over 9.
I'm probably getting green.
7 over 9.
Yeah, so the 7 part hasn't changed, but the bottom fraction has changed because on the second go, you have 1 less disc. So the bottom number has to change. So excellent. Okay, let me just rub this bit off here. Let's do some questions now. Okay, carry on, Arwa. If both discs are green, what's the probability going to be?
7 over 10 times 6 over 9.
7 over 10 times by 6 over 9. What's the answer from that going to be?
42 over 90.
Probability that the both will be blue.
3 over 10 times 2 over 9.
Which gives us
6 over 90.
which is probability of a blue and probability of a blue. And what about the next one?
You have to do like green and blue. So 7 over 10 times 3 over 9.
Or
Plus 3 over 10 and 7 over 9.
so 7/10 times by 3 over 9. You got 3/10 times by 7 over 9. And what do you do to both of these answers?
Add them.
Add them. So that gives you 21 over 90. Yeah, 21 over 90 gives you.
42 over 90.
Okay, done. So in these questions, you have to understand that the fractions change on some questions because of the wording of the question. They're telling you they haven't put the stuff back in. Okay, are you happy with that? Some people are really tired.
I took one gas.
Mhm. Okay, question for you guys. Question number 3.
Oh. Wait, do you want to say this?
Anyway, we have space.
No.
Question number 3, everybody have a go. It's got 5 red, 3 blue, and 2 yellows. Oh, okay. Okay, now this one's actually got 3. Give me a second. Let me adjust it a bit because I want to just do. I want you to do it as a 2 question. So for the moment, otherwise we're gonna have. So do as 5 red balls and 3 blue balls. Okay, and then we can have that one can stay 1 blue and 1 red, and we can have 2 blue, and we can have 2. Okay, yeah, now you can do it. I've done a little bit of editing. I've taken the third just to keep the question a little bit more simpler, so it looks like this kind of question. Okay, it's not gonna have 3 late. You're not gonna have 3, 3, 3. That's whatever. Okay. What is there on split here?
They're going to be different because you change your answers.
Okay. Question number 3. Probability of getting a red and probability of getting a red will be equal to what? Let's have Mr. Abdul Hamid. What's the probability of getting red and red? Just give me the values minus the tree diagram. So the first one will be what? 5 over 508. And the second one, Abdul Hamid, will be what? Okay, you won't go from 508 to 308. You'll go from 508. If you do the same event twice, you'll go from 508 to 4/7. Because you lose one. So that gives us 20/56. I'm not counting the moments, leave that there. Okay. For question B. For question B, let's have SN. One blue and one red. Probability of a blue and the probability of a red. Now, they haven't given you the order, so you have to assume that you're going to do probability of a red and the probability of a blue. Because if you want to get those two colors, you can get them in any order. Okay, what's SN? Values, please. Come on.
30/56.
Say that again.
Is it 30/56?
Wow, mashallah, you're teaching us answers now. I never knew this was an answers class. I thought it was a maths class. So aren't you going to give us the maths, or you're just going to learn, we're going to learn the answers?
Oh, you do 5/8 times 3/7 and 3/8 times 5/7.
Oh, so 5/8 times by 3/7 plus 1. The red one will be 3/8.
Over 8 times 5/7.
Lovely. Okay, that will give you 15/56. Add 15/50. Oops. 15/56, and then together gives us
30/56.
That's better. Now you're talking sense. Okay, question C. Let's have Asadullah. Two blue ones.
Will it be 3/8?
Time by
3/7?
gives us
6/56.
yeah, done. Okay, D. Right, for D, let's have Salia. D. Probability of blue and blue, or probability of red and red. So that we just steal the answer from above.
6/56.
And what's the red?
And 20/56.
Just steal the answer as well.
26/56.
Fantastic. Fantastic. Okay, right. So we've done enough of those. Let's get back into the examination questions and smash these to pieces. Okay.
I think so we don't have to do them.
Which ones? I didn't draw them.
These ones now have to do them.
Oh, yeah, on these ones, well, you don't even need to draw them. You watch. You who said we're going to draw them? Who said we are going to draw them? Okay. Here we go. Question number 24. Let's have question number 24. Let's have Eliza. You do the next one. Eliza, please. Number 24.
There are 5 red pens, 3 blue pens, and 2 green pens in a box. Gary takes a random pen from the box and gives the pen to his friend. Gary then takes at random another pen from the box. Work out the probability that both pens are the same color.
Okay, so now by looking at the language, the key word is, what does that mean?
He takes one out.
And does he put it back in?
No.
Okay, lovely. So when it's not being put back in, what do we call that?
Without replacement.
Oh yeah, without replacement. Without. Fantastic. So probability of the both pens being the same color. Give me the idea. So there'll be probability that the first one is red and the second one is also
red.
Now,
and then
or the first one is
blue and blue.
And the second one is also blue. Or the first one is
green. And
the second one is also green. Yes?
Yeah.
Right. Don't do what I've just done there. I've kind of gone into the marker, the examiner's one. It's okay. Let's get back in. So go on then. So give me the fraction for the probability of the first red one. So it'll be 5 at 3 at 2. How many do you have altogether?
10.
10. So the first part of the probability it will be 10 for each one. Is that right?
Yeah.
Right. And the next part of the probability will be always what?
9.
9 has to be 9. Why is it so fat? It has to be 9 because you've taken one out. Okay. And what does the and mean?
Times.
Or means?
Add.
Okay, lovely. So what's the probability of the first red one?
It'd be 5.
And the second one that you take out?
4.
4, lovely. Because you're taking one out, you lose one from the top, one from the bottom. And what about the blue?
3 and 2.
And the next one, a green?
2 and 1.
You know what? Can I do 2 bags?
It's actually yours. So 5 times by 4 is 20 over
90.
plus
6 over 90.
add.
2 over 90.
Okay, and then the final answer is
28 over 90.
lovely. Fantastic. You can cancel it down as well if you wish. Done.
Wait.
And the key part of this question is which part? Is you are having a correct idea part, understanding that, and then realizing that the fractions will change each time in the question. Are we happy with that, Anaya? Say Inaya, the I. Probability of the same color we done before. Probability same color means red, red, blue, blue, or green, green. But you have to say to yourself, so or it's going to be either 2 reds or 2 blues or 2 greens. Okay, that's what you're saying. That's your idea. Okay.
And is this sheet for homework?
Yeah. Okay. Question number 25, Anaya. Your turn. Go. Carolyn.
Carolyn has 20 biscuits in her tin. She has 12 plain biscuits, 5 chocolate biscuits, 3 ginger biscuits. Carolyn takes a random 2 biscuits from the tin. Work out the probability that 2 biscuits are not the same type.
Okay. So probability that they are not the same type. Not the same type means they can't be. It can't be plain, plain, or chocolate, chocolate, or ginger, ginger. Okay, so how would we think about this question? Give me an idea. So if they were the same, what would it be if they were the same? Or what we would work out? Probability of plain, plain, or probability of chocolate, chocolate, or the probability of ginger, ginger. If the wording was that they are the same. So how do we change that wording from are the same, which is easy, we understand that easily, to not the same?
You just get one and take 3.
Fantastic. Now, folks, pay attention, please. Anaya is saying this is a method for working out something which is not. Probability of something not happening is 1 minus probability of it happening. That's what we've just done here. We've done the question the easy way. Hopefully, we'll have fewer number of calculations by using this principle. The probability of something not happening is equal to 1 minus it happening. Okay, another question to you, Abdullah, at the back. What's probability of not happening and happening equal to? 1. Just rearranging it. That's where it comes from. So the probability of something not happening is, if we do the inverse, is 1 minus it, that it will happen. And that's what we've just done here. So let's set up the question. So hopefully we'll have less calculations. So probability of plain, plain. It says it takes 2 biscuits from the tin. Now, Anaya, does it mention that she put them back in? So what do we assume? That she didn't put them back in. So this question is with or without replacement? Is it with or without replacement? Allahu Akbar, you have difficulty in speaking English now. without replacement. We're gonna have to get speech therapist for this girl. Yeah. So if anybody knows any good speech therapist, please send me a message and we can just get this girl connected with the right person. Sorry. Probability of plane. Okay, let's have Salia. Probability of plane. So 12 out of 20 times by 11 out of, because you're picking the second one out. O means add. Next one, Anaya. It's like Inaya. Probability of chocolate.
5 over 20.
5 over 20 times by 4 over 19. Lovely. Let's have Eliza. Probability of green ginger. I was about to say green.
320 times 219.
Okay, lovely. So what's 12 times by 11? Let's have Salia 100. That's his mom. Okay, right. I can't answer for a moment. So 12 times by 11 is 132. Oh, what's 20 times by 19?
Oh yeah.
20 times by 19. Okay, everybody's on silent. 380. And the next one will be 20 over. And the next one is 6 over. Okay, now. Are we getting stuck with the 11 times table, Anaya? You got that kind of confused look on your face. Yeah, we had one student telling us it's 121 or something. Yes, she needs to take a quick vaccination for 121. Okay, right. Has Abdullah, have you added? Has anybody added the top numbers for me? Because everybody at home seems to be like, what gives you?
158.
158 over 380. Now remember, 1 is the same as what? You can change 1 into 380 over 380. So what's the answer to that then?
222 over 380.
No, but the brain cells are working in the class.
We could simplify that.
You could, yeah, of course, can. I'll let you use that for us. Ooh. Right, let's do number 26. Let's try to squeeze in the last question into the before we go. It's got Fizza. Was actually one of my other students' names. Okay, now don't call her Pfizer because she actually got offended with me. She didn't start calling her Pfizer. Yeah, it's Fizza, not Pfizer. Or Johnson and Johnson's, or what's the one called? Megatron and Bumblebee and Oxford Zeneca. Yeah. Okay, right. Let's have question number 26. Let's have Mr. Asadullah read for us, please, and help us.
Fizza has 10 Fizza has 10 coins in a bag. There are 3 £1 coins and 7 50p coins. Fizza takes at random 3 coins from the bag. Work out the probability that she takes exactly £2.50.
Hoi, hoi. Throw the coins.
So yeah, you should have like different combinations of whatever she wants.
Okay, so work out the problem that she takes exactly £2.50 now. That's question number 26, worth 4 marks. Right, so off we go. So how do we understand this? So what are the ways that we can make exactly £2.50? Now, if she goes, she takes a random 3 coins in the bag. Has she mentioned in the Asadullah that she put any of them back in?
No.
So what do we assume? If she didn't say that she put them back in, did she put them back in or not put them back in?
She didn't put them back in.
She didn't put them back in. So this question is also without replacement. Okay, lovely. So So can you give me the different ways you can make £2.50 using 3 coins from above, please? Go. You can have probability of a £1,
£1, £1 and a 50.
Or you can have probability of a
£1, 50 and 1.
Or
can have 150.
No, that's already done.
Oh, so it's 51.
Fantastic. Are there any more ways? Anybody else in the class? Can we make any other ways to make the £2.50 apart from those 3 ways? You can't because you can only use 3 coins.
So can't you do like 50, like 4 times, and then you get
Okay, now remember what the key thing in the question was: how many coins are you allowed to use?
oh,
Big.
okay.
Okay, so this actually, what he told us was correct. That's all we can do. So let's go. Let's put some layer of maths on. Probability of the first £1, so the low, what's the probability of the first £1?
3/10.
And the second one?
2/9.
And the first 50p?
7/8.
Allahu Akbar, fantastic. So now we have the numbers changing 1 each time. So we're going from
Then
10
yeah, add it.
to 9 to 1. We're changing it. Okay, O means plus. Probability of the first pound is 3/10.
Yeah,
The
and
first
plus
50p,
7/9
7/9, because 1 coin's been taken out.
and 2/8.
2/8. Fantastic. And the last one, the first 50 is 7
7/10.
time by
3/9.
time by
2/8.
fantastic. And it's all about the idea. This is the correct way of thinking of the question. So 3 times by 2 times by 7 gives you what on the top?
42.
And does it give us 42 on the top for each one?
Yeah,
And what does it give us on the bottom each time?
720.
And what's our final answer?
126/720.
126, 40, 40, 40. And then you can cancel that down if you got the energy and you want to work that out.
Yeah, 7/40 if you cancel it out.
Okay, so we have literally, now I haven't done all the questions. I think there's one question left, which is a nice, actually exciting question, by the way. Now, okay, now there's some questions over here. We would have done, I think, one of the most important questions here. Okay, now these particular questions that we've done in this pack here, I want you, if you're home, to have a second copy. If you need the copies from me, you just need to let me know. Give me a second. Wow.
This is awesome.